Welcome back to Work in Progress. Today, we'll take you on an extraordinary journey to witness the manual manufacturing of a supergiant gear. This process relies on skilled technicians, basic tools, and machinery like forklifts, but no automation or advanced CNC systems. It's a true demonstration of human ingenuity and craftsmanship in an analog industrial setting. Let's jump right into it. Step 1. Designing and preparing the blueprint. The process starts with engineers drafting a detailed blueprint of the gear. Instead of CAD software, this is done manually on large drafting tables using rulers, compasses, and stencils. Every dimension, from the diameter to the number of teeth, is calculated and marked with precision. The blueprint is then handed off to the workshop team. Step 2. Forging the gear blank. A large steel billet, weighing several tons, is brought into the factory and heated manually in a coal or gas-fired furnace. Skilled technicians monitor the billet's color to gauge its temperature. Reddish-orange indicates it's ready for forging. Using heavy hammers and basic hydraulic presses, the team painstakingly shapes the billet into a rough circular blank. Forklifts are used to move the billet between the furnace and the forging area. Step 3. Rough shaping the gear blank. Once cooled, the rough blank is mounted on a large, manually operated lathe. A technician uses hand-cranked mechanisms to rotate the blank and manually adjust cutting tools. The operator carefully removes excess material to achieve the approximate dimensions of the gear. This process demands incredible focus and expertise to ensure uniformity. Step 4. Marking and cutting the teeth. Here comes the most challenging part, cutting the gear teeth. First, the blank is marked manually using chalk lines and a gear template, which is carefully aligned and pressed against the blank. Using chisels and hammers, technicians create grooves where the teeth will be carved. Next, they use a manually operated gear cutting saw to shape each tooth. This step can take weeks to complete, as each tooth must be individually measured, cut, and filed for precision. The technicians frequently inspect their progress with simple tools like calipers and straight edges. Step 5. Heat treating the gear. The semi-finished gear is moved back to the furnace using forklifts, where it's heated again to enhance its strength. After reaching the desired temperature, the gear is manually quenched in a large oil or water tank. Technicians control the quenching process by using paddles to ensure even cooling, a critical step in preventing warping or cracking. Step 6. Polishing and finishing the teeth. Once cooled, the gear is polished by hand. Using grinding stones and files, technicians smooth out the teeth, ensuring that each one is uniform in size and shape. This step requires extreme patience and precision, as any misalignment could affect the gear's performance. To check for accuracy, technicians manually test the gear by rolling it against a test pinion, making adjustments as needed. Step 7. Surface treatment. To protect the gear from rust and wear, it's coated using a manual spraying system. Technicians apply the coating evenly across the surface, often using brushes for hard-to-reach areas. This layer ensures the gear can withstand harsh industrial environments. Step 8. Assembly and final testing. Finally, the gear is hoisted using a combination of chain pulleys and forklifts and mounted onto a test rig. Skilled workers manually align it with a test pinion and crank the mechanism to simulate its operation. They listen for unusual noises, check for smooth movement, and inspect for any wear on the teeth. Once everything checks out, the gear is prepared for delivery. Given its massive size, transportation is handled using forklifts and manually guided cranes. And that's how a supergiant gear is manually manufactured. From the furnace to the filing station, every step is a testament to the craftsmanship of skilled workers. It's labor-intensive, time-consuming, and requires unmatched attention to detail. But the result is a work of engineering excellence. What are your thoughts on this incredible manual process? Which step impressed you the most? Let us know in the comments below. If you found this video fascinating, don't forget to like, share, and subscribe to Work in Progress. Hit the notification bell to stay updated on all our future videos. Thanks for watching, and see you next time.